Hi, class. I am going to go over the notes for section 4.2 on reflections. Now, I already did this in class with you all, so I'm just making this video in case you need a refresher or maybe you missed class. So this page are your basic definitions. Your book says a reflection is a transformation that uses a line like a mirror to reflect a figure. But in class, we like to keep things simple and say things in our own words. So just remember that a reflection is when you flip an object. You could flip an object over a line, over the x-axis, over a slanted line, etc. A glide reflection is a transformation involving a translation followed by a reflection, which means the object will slide and then flip. A figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection line. So what this means in basic terms is I can have a figure like a triangle. And if I draw a line through the triangle and I see that if I were to fold this triangle over the line, the left side will totally match the right side. Or if you just look at it, we see that on both sides of the line is exactly the same. We see then that this figure has line reflection. So line symmetry. So we will say, yes, this triangle has line symmetry, and I was able to make one line of symmetry. This is an example of a glide reflection. So the pre-image is this blue triangle here. And when you do glide reflections, you have to go in order. So the first transformation is the translation using the rule x minus 12y, which means that the blue triangle went to the left 12 units. Then the reflection is taking the one that got translated, the red one, and then do the reflection rule, which is reflection over the x-axis. So the red one got flipped over the x-axis to form the green triangle. And a reflection is a rigid motion. Glide reflections are rigid motions. Remember, rigid motion means the figure will keep the same size and shape when it is translated. So for reflections in the x-axis, this first diagram is this is a reflection in the y-axis, my mistake. So the triangle on the left is the pre-image, and the line of reflection is the y-axis. The coordinates of the pre-image are as shown, and the coordinates of the image, which is over here, are as shown. If you look at the coordinates for points A, B, and C, from the pre-image to the image, you might notice that for all the X numbers, the sign changed. See that? The 3 went from negative to positive. For point B, -2 turned positive. And for point C, -1 turned positive. So the coordinate rule for reflecting over the y-axis will be -xy. Negative x means change the sign of x, and y means keep y the same. Please do not think negative x means x will always turn negative. Whatever the x number is, change the sign. And whatever the y number was, you keep it, okay? The next example is a reflection in the x-axis. So triangle ABC is your pre-image. And here's the coordinates. And triangle DEF is the image. This time you should notice that the y coordinates change signs. +1 changed to -1. +3 changed to -3. So the rule for reflecting over the x-axis is x negative y, which means whatever your x coordinate is, keep it the same, but change the sign of the y coordinate. So here I did a reflection of triangle ABC over the x-axis. Now you can use the coordinate rule if you want, or you can just use the graph. So if I'm reflecting over the x-axis, that means I move the point, I keep it on this same line, so it's on the same line, but instead of being 2 blocks above the x-axis, it's going to be 2 blocks underneath the x-axis. Okay, so basically in the same spot, just on the other side of the line. I did the same thing for points B and C. Point B was 5 spots or 5 units above the x-axis. So when I did my reflection of B, I put it 5 units below the x-axis. Or if you use the coordinate rule, you know that the x number stayed the same and all the y coordinates changed signs. For reflection over the y-axis, the x coordinates change signs, the y remains the same. Of course, 0 is neither positive nor negative, so you don't put -0. Also, it's good to know that anytime you have a point that is on the line of reflection, when you do your reflection, that point will not move. So point A was on the y-axis, which is the line of reflection. So when we did the reflection, point A and A prime is the same coordinates. B and B prime change coordinates. Again, you could just use the graph if that's better for you, or you can use the coordinate rule. And know that point B stayed in the same spot, just on the other side of the reflection line. So here we're reflecting over slanted lines, okay? So in this first example, this is the line y equal x, okay? The reason why they call it y equal x is because every point on this line, the x coordinate and the y coordinates are the same. For example, you got point 1, 1 on there. You got points 3, 3 on there. -2, -2, etc. Okay, so that's the line y equal x. It slants in the positive direction because it has a positive slope. So segment FG is our pre-image, the blue segment FG. Coordinates are shown. The image of segment FG is the red one, FG, F prime, G prime, sorry. The pattern you should notice is that the coordinates switch places. They just flip-flop. They didn't change any signs, they just flip-flop. So the rule for reflecting over the line y equal positive x is yx. That means flip the numbers, do not change any signs. Okay? Now for y equal negative x, so that's this line here, y equal negative x. And basically, every coordinate on here, whatever the x is, the y is a different sign for this whole line. Like you got -1, +1. You got 2, -2, etc. So again, looking at segment FG, the red one, those are the coordinates. And then the blue segment, F prime, G prime, that's your image. You should notice this time that not only did the coordinates switch places, they also changed signs. So the rule for reflecting over y equal negative x is negative y, negative x, which means flip the numbers and change all the signs, okay? If it was already a negative, you will change it to a positive. If the sign was positive, you'll change it to negative. So here I did a reflection over the line y equal positive x. I drew the reflection line on the graph. Now, I'm not that good at reflecting over slanted lines visually, so I like to use the rule for reflecting over y equal positive x. And the rule is yx. So I just took each coordinate and I switched them. See that? No signs changed. They just switched places. The y and the x switched places. Now, if you were to do it visually, there's a way you can do it visually. I call it the over and down method. So what I did was, look at point S. If I travel horizontally to my reflection line, I would have had to go over, what is that? 1, 2, 3 blocks? 1, 2, 3 blocks. Oops, purple. So then I traveled the same number of blocks going down. Okay, I went over to the reflection line 3 blocks. So from that point on the reflection line, I traveled down and I landed here for S prime. The over down method works every time. So if you rather use the graph and you have a hard time reflecting on a slanted line, you can use the over down method. Some people have a hard time seeing how that is truly a reflection because the reflection line is slanted. But I tell people if you were to turn the graph so that your reflection line is horizontal instead of slanted, then you should be able to see, yes, point T went straight across the reflection line. So did point S and point R. For the line y equal negative x, remember it's a slanted line with a negative slope, okay, going through 0 on the graph. The rule is negative y, negative x. That means each number, that means your x and your y switch places and you change the signs of everything. So I use the rule for my coordinates, but here is my graph. Again, the over down method will work. If I look at point A, I would have to go over 2 blocks to touch the reflection line. So from there, go down 2 blocks. Point B and C, same thing. Point B is like how many blocks? 9 blocks going over. So then from there, you would go 9 blocks down to reflect point B. And again, if you have a hard time seeing, if you turn your graph so that the reflection line is straight up and down, then you can see how each point traveled directly across the reflection line. Other lines on the graph. So for this first example, so you don't always reflect over the x and y axis or the slanted line y equal x or y equal negative x. You can have other lines on the graph. So for number 1, this vertical line is crossing the x-axis at positive 3. Every point on the vertical line has an x value that's 3. Okay? This point is 0. It's 3, 0. Then you got 3, 1, 3, 2, 3, 3. You got 3, negative 1, etc. So the equation for that vertical line is x equal 3. Okay? For this horizontal line for number 2, that line crosses the y-axis at positive 1. And every point on the line has a y that is 1. This point is 0, 1. Over here you got 1, 1. You got 2, 1, 3, 1, 4, 1. Over here you got negative 2, 1, etc. So that equation is y equal 1 for this line. You need to know that any line whose equation is x equals some number, it's always going to be a vertical line, and that vertical line crosses the x-axis at wherever the number is. If your equation says y equal some number, then that will always be a horizontal line that crosses the y-axis, and it crosses the y-axis at wherever that number is on the graph. So finally, we have, in this example, you take triangle RST and reflect it over the line x equal 1. So on the graph, go to the x-axis at positive 1, and then just draw a line straight through positive on the x-axis. Okay, the line is vertical because the line crosses the x-axis where x equal 1. Now there's no rule. After that, you're going to need to use your graph to determine where each point lands after you make your reflection. Point T was 2 spaces on the left side of our line of reflection. So when you flip it, point T landed 2 spaces on the right side of the line of reflection. Same thing with point S. Point R was 1, 2, 3, 4 spaces to the left of the reflection line. So when we flipped it, point R is now to the right of the reflection line. Once I graphed my points, I used my graph to determine what the coordinates are. And for the line y equal 1, which I did down here, so I went to +1 on the y-axis, and I drew a line straight through the y-axis where y equals 1. So that's a horizontal line. And so again, each point got reflected over the line of reflection. So point R was only 1 block above the line of reflection. So it's going to be 1 block underneath. Same thing with point S. Point T was 1, 2, 3 blocks above the line of reflection. So underneath the line, I had to go 3 blocks under for point T. I hope this video helps you guys. Please remember to complete the slides and then save a copy for yourself. Submit this on Google Classroom so I can give you credit for your work. Let me know if you have questions, send me a message, or come see me for help. Have a good day.